Hi Year 3 and welcome to this week's science lesson. So we're carrying on with our new topic of forces, and today we are going to be doing a bit of an experiment, a bit of a test. So let's have a look. So we're going to be thinking about this question here, which is how do things move on different surfaces? And today we're going to plan a fair test to answer this question. So we're not actually doing the experiment today, but we are going to plan the experiment. So this is what we're going to be doing. So we're going to be getting a car, a ramp, and then we're going to be doing a different surface down the bottom to see what happens. So here are some ways that you can make your ramp at home. So for next week's lesson, these are some different ways that you could do it. So you can see here we've got some books lined up. We've got a book and a piece of card. We've got some blocks. Got some piping. There are lots and lots of different ways we can make it. So if we're back in school, then we will do it in school. But if not, then these are some ways you could do it at home. So how do things move on different surfaces? So we need to think about our method now. So we need to change one thing in our test so that we can measure the results. So we are going to change the surface at the bottom of the ramp. And we are going to measure how far the car travels. So that is what we're finding out. We're finding out if we change the surface at the bottom of the ramp, does it affect how far the car travels? So we're talking about a fair test. So some of you might have heard of a fair test before, but if not, a fair test is something that we need to do to make sure we have accurate results. So to make something a fair test, we can only change one thing at a time and everything else has to be kept the same. So we're going to think now about some of the things that are going to be kept the same. And this is the only thing we're going to change. So the one thing we're going to change is the surface at the bottom of the ramp. So what should we keep the same? So there are lots of different things here. So you might want to pause the video and have a quick think about which ones of these we need to keep the same. Not all of them, but some of them are going to be very important that we keep them the same. So just pause the video and have a think about which ones are important. Okay, so hopefully you managed to get a few of these. So how many people are watching? It doesn't really matter. It won't affect the results at all if there's 2 people watching or if there's 30 people watching. So that one, it doesn't matter if we keep that the same or not. The person who lets go of the car, that's quite important that we keep the same because we might do it in different ways. So if it's always the same person, then they will know how they let go of the car and they can try to do it as accurately as possible. The car needs to stay the same because obviously different sizes of cars, different weights, different shapes might move differently. So we want to make sure that the car stays the same as well. The number of people in each group, again, a little bit like how many people are watching, it doesn't really matter. As long as it's the same person letting go of the car, that is all that matters. How we let go of the car needs to stay the same. So if we're holding it and we just let it go like that, that's going to be different than if we push it. So we need to make sure each time we do it in the same way. The ramp needs to stay the same. So whatever ramp we're using needs to stay the same. It's just the material at the bottom that is going to change. The height of the ramp needs to stay the same. So if you're using books or if you're making out of cardboard, we don't want to make it any higher or any lower between each one. We want to keep it the same. Where the car starts, that obviously is really important to keep the same. So we want to put it on the same point each time. Now, the 2 things that are going to change is how long it takes the car to go down the ramp, because obviously that is what we are measuring, and the surface at the bottom of the ramp, because that is what we are changing and what we want to find out. Okay, so what surfaces will we test at the bottom of the ramp? So if we are still doing this at home, don't worry if you don't have all of these. You might have some different ones at home that you could use, but if we're in school, we're going to be using some of these. So we've got the carpet we can use sandpaper, we can use bubble wrap, corrugated card or tin foil, and you might be able to think of some different ones as well. So you might have some materials at home that you could use. So when we change the surface, how far does the car travel? So we are going to make a prediction, and a prediction is what you think will happen. So we don't know what will happen. Even if we've done something like this before, we can't predict completely what's going to happen. So we need to predict, which means we're going to sort of make a really good guess. So we don't know what's going to happen, so we need to predict it, which is, like I said, it's making a sort of reasonable guess on what we think will happen. So our prediction, so there's a little bit of a template for you here, which will also be on the website. So I predict that the car will travel the furthest if the surface at the bottom of the ramp is, and then you need to fill in the gap. So you might say that you think it will travel the furthest if it's smooth at the bottom. You might think that maybe if the corrugated card was there, you think it will travel furthest. And then why? So this is because and why. And then there's a more challenging one here as well. So if you want to challenge yourself a little bit, you could use this one instead. And this is where it has both. So it says which one you think will be the furthest and which one you think will travel the least furthest. So this is an example of a prediction. So it says, I predict that the car will travel the furthest on the foil. This is because the surface will be slippery and smooth. I predict that the car will travel the least far on the sandpaper because it is bumpy and rough. So that is an example of a prediction. So that is what you are going to write out today, because we're not conducting the test today. We are just going to predict what we think is going to happen. So there will be a sheet on the website for you to fill out with your prediction. Then the last thing we just need to think about is what equipment we will use to measure how far the car has travelled. So we're probably going to want to use a ruler. We might want to use a meter stick, but we're going to want to use something that's quite accurate. So we could use something like a piece of string, but actually if it comes down to it and they're really close, then we're going to want to see exactly how far it has travelled, which will also tie in nicely with our maths unit on measuring. So that will be really useful for doing this. So that is all for today. Like I said, your activity, there is a sheet attached on the website. So it's a planning sheet and talking about what we're going to change, what we're going to keep the same, and then our predictions. So that is what you need to do this week. And then next week, when we're in school, hopefully we will conduct the test in school. So that is all for today. If there are any questions, please do get in touch, and I hope you enjoy. Bye.